Math is super fun. Slope is rise over run. I be chillin' in the sun.
Hey stats lovers, let's go over quiz number 4, 2-1 and 2-6, taken on November 9th. Question number 1, each of the following settings explain which variable should be the explanatory variable and which should be the response variable. Then classify each variable as categorical or quantitative. The stroke of a swimmer and the outcome of the race. The outcome is just you got like first place or you're the winner. That's two N's. Second and third place, something like that. And then over here, the type of stroke you have, backstroke, you have freestyle, butterfly, things like that. Okay? So, the outcome of the race. Well, when is the outcome? Usually the outcome is towards the end of the race, so that would be the response variable. What we talked about are the first place, second place, third place. Are those things that you would kind of take the average of? No, they would not. Those would be categorical. Stroke of the swimmer is the explanatory, right? I don't know much about swimming, but I'm assuming that the different type of strokes will give you different types of speeds, right? Maybe the butterfly is a little bit slower, or it looks like it. And the word back, free, and butterfly, you would not take the average of, so that would be categorical. Number 2, I have, according to the table above, which of the following is the closest to the equation for the line of best fit or the linear regression? What is the correlation coefficient? Okay, my correlation coefficient is an R value, and the line of best fit is just linear regression. So I'm just gonna make this row here the X values, and this one I'm gonna put into the calculator. Go ahead and press pause if you need to input that information, or I already have input into my calculator. Graph and Calc 83 here. I'm gonna turn off my dark mode because I realize I've lost some functions when I do that. So to get here, I just want on the home screen, second quit, clear, stat, edit, and what I did there is I put into list 1 the years, and list 2 I have the population. Okay, so I'm gonna press second quit. I want linear regression. I'm gonna press stat, calc. On mine, you have number 3 there. You also have number 5 and you have number 9. 5 and 9. So it does not matter for 5 or 9, you just need to pay attention to the number in front of X, which is your slope. So I'm gonna do number 5. And I need to put in list here. So you can go to second stat, or you can use the keyboard function, second 1 and then second 2. So second 1, comma, second 2. And then it tells me the frequency list. I just want that one time, and then I'm gonna do something different here. It says the formula right there, it's a regression equation, reg EQ. And I want that to store it in a certain location. So I'm gonna press vars, y vars, and I'm gonna go ahead and store it into y1. Okay, so there's my formula. A is 318, and A is in front of X, so that's my slope. So my equation would be y equals 318 X plus my B value is my y-intercept, so negative 620,000, and my correlation is going to be R. Okay, so another thing, let's just go back and answer that question wherever I put it. Here it is. Okay, so this one's going to be choice B. Now it's kind of weird because this one does not have y equals in front of it, but that's okay. That's okay. For question number 3, according to the data, predict the resident population in Florida. in 2020. So 2020 would go here, and that is, couldn't fit it there, 2020, and it's an x value. So I need to put in x equals right there. And you can do this with that equation above, or you can just put it into your calculator. Watch what I'm going to do. If you followed my commands, why did I put it into y1? So if I go into y1, it's already in there. Let me go ahead and delete this one. Okay, it's already in here. And you could do a couple things. You can do table set, so second table set. And I'm going to be on ask, when I want the calculator to ask me. Okay, so now if I go to table, if I type in 2020, then the y1 answer goes in there. All right, it just erased all my answers. Wonderful. But our answer for number 3 is C. Number 4. Total box office gross. Like, how much money are these movies making? According to the table above, which of the following is closest for the equation for the line of best fit and then correlation coefficient? So here in green, this will become my x. And then in blue, this is what I put into my y. Okay, so let's go there. I already input into my calculator. Stat, edit. I put mine into list 3s and 4s, if you can see that. Okay, so I'm just going to go back out. I'm going to do the same calculator command, stat, calc, number 5, lin reg, ax plus b. So now I have it in list 3, so I'm going to press second 3, second 4, and then where do I want to store this? So vars, y vars. And what's nice about my tablet, iPad app, it's telling me which ones are free. So I'm going to put it into list or y2. Okay, so my slope is 244 and my y-intercept is negative 481 with a correlation coefficient of 0.855. Okay, so that would be choice B. Number 5, it gives me a year. So the years, is it x or the y? So that would be x equals 2015. So we're trying to find a y value. You could just put it into this equation here. And you get an answer, but I can just let the calculator calculate all that. So let me put in 2015. Again, so I'm going to go y. I'm going to clear out this one. So now I'm going to go to second. I already set up table set to make sure it's on ask. So just press table and then type in the year you want. Do we say 2020? Help me, guys, help me. What did I say? 2015. Okay, so that'll give me 11,783. 11,783. Uh-oh, something went wrong. 244 minus 481219. $244,241925. And then we typed in 2015. Uh-oh. Fine, to ask. Just checking my answer should have been not that. Well, the correct answer, oh, it was matching, right? Okay, question number 6. Tables above represent the previous two questions. Which has a stronger correlation? So stronger in this case means either closer to -1 or +1. Let's take a look. So for this one, I have 0.85. Let's see if you go up. Let's see. It did store it. 0.99. So that is the first one. So Florida is our answer. All right, question number 7. Guess that doesn't really help me. All right, I'm gonna add it on the screen. We have positive correlation, no correlation, negative, no, and then there's also says causal or causation, and then the other one is association. Let me talk about these for a second. All right, for causation, a couple other words I'm going to write in here to help us review what it is. All right, let's go over causal and association. In causal, the question is, does X cause Y? We're using one variable produces a change in the other variable. Change in other variable. How do you do that? You have to test them or compare them or do an experiment. So to prove causation, or something causes the other, you have to do these, okay? For association, it's just another word for correlation. It's determined from data collection in a controlled experiment. We usually visualize this or pick an association by a scatter plot. So putting a bunch of dots, and really it's an observation we're looking at. Okay, so with this information, let's go ahead and go over this one. The number of practice free throws you take, and the number of free throws you make in a game. So again, if you get stuck on these, good idea is just drawing. So this is practice 0 to 100. So you're taking a lot of free throws. And then what would you expect on your game time free throws? Well, I expect that you take little, you'll make little. You take maybe 50, hopefully you make those during the game, or your percentage. So I would say that it has a positive correlation. Okay, does X cause Y? It's hard to do a controlled experiment for a game time prediction. Does that make sense? Like in practice, you might take 100 free throws, but you can't take 100 free throws in a game. So I think you can make some observations, or I think there's an association is the correct answer. All right, the second one, the number of hours you use your Bluetooth. Hours used, so we'll say 100. And then battery life. So, in the very beginning, hours used, it's probably at 100. And if you use it 1 hour, you might have 98%. And if you use it 100 hours, then you'll probably have 0% battery. So I would say that this one is a negative. But does the using of your headphone batteries, or just using your headphones, is it going to decrease your battery? Does it cause it? Yes, it does. You can do that over and over again and prove that. Okay, the third one, the number of hours worked and paycheck amount. So if I worked at Jamba Juice, hours worked, 0 to 100, and my paycheck or money, $100 to 0. So if you work 0 hours, you have 0 money. Work 1 hour, you have like $10. Well, $6.25, that's how much I made. And then 100 hours, you're gonna get lots of money, like $100, right? So what do you have? You have a positive correlation. Okay, is it causation or association? Yes, you can put it on a scatter plot. Yes, you can make those observations, but the more hours you work, the more money you have. It causes the other one, right? Hours work causes increased money. Okay, and the last one, a man's age and amount of hair he has. So you look at my dad's, I'm gonna look like my dad soon. So age, 0 to 100, and hair, let's do a hair percentage, right? So that was 100. So my son was just born and he has lots of hair, and then when I'm old like my dad, I'm gonna have like 2% hair left. So what do you have? That is a negative. Okay, so is there an association or causation? Well, there are some guys who will not lose their hair. So we can't say cause. We can say that there is a association. You could probably say a strong association, but we cannot say definitively that as you get older you will lose your hair. Does that make sense? Number 8, table shows the distances that schools will travel to attend a field trip to state capital. School 7 has, so this is what's add school 7, 15 miles. If this outlier is added to the data, which statement is true about the changes in the data? So, you can just quickly graph these. 2, 3, 4, 5, 6, 7. School, and then distance. Let's just do 1, 2, 3, 400. So 1, 425. School number 2 is like 150. 3 is at 400. 4 is at 380. Kind of all over the place, right? 5 is at 200. School 6 is 380. And lo and behold, 7 is at 15. So if I kind of just draw what I think is a line of best fit through the blue, you might have something that looks like that, right? But with that yellow line, I'm probably going to gravitate towards this one. Okay, so what's happening to my data? Is it less spread? We need to choose all that apply. So is the data less spread or more spread? Well, it's more spread because you're going from before this used to be the minimum, now 15 is the minimum, right? Does that make sense? Remember? More spread is more variation. Both the mean and median change. You can run the numbers. There's no change in the median. That one happened. There has to be some kind of change. There's no change in the spread of the data. No, the standard deviation will change. Okay, the median stays the same, and the mean changes. So you have to think about which one cannot resist the outlier, and it's the mean that cannot say no. So 2 answers are B and F. Look at G, the median changes and the mean stays the same. You guys could have just listed out the numbers 200, 380, 380, 400, 425, and 15. Does that make sense? And then you can just use your old school. The median stays the same. Now, if you didn't have that number, if you're looking here in just this yellow box and those numbers, then the median would have been 380. So the median stays the same. That's true. This one is not. Okay? All right, those are our quiz corrections. Hope that helped you guys study. We'll see you guys later. Bye.
It started out with graphing and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3. Now you make that point on the x-axis. Wait, was it a positive 3 or a negative 3?